Welcome to qnawire.
Hi there. So for this problem, we are told that a sphere of radius r surrounds a point charge q located at its center. So for part A of this problem, we need to show that the electric flux through a circular cap of half angle is given by the following equation, and that is the charge q divided by epsilon sub 0, 2 times epsilon sub 0, and this times 1 minus the cosine of theta. So the electric field due to the point charge is uniform and points radially upward. So we know that the electric flux is the product between the electric field and the area, and the arc length of a small ring-shaped element of the sphere that we are going to call the S is equal to the radius times the differential in theta. And its circumference is going to be, its circumference is 2 times pi times the radius, and that is equal to 2 times pi times the radius, capital R, sine of theta. So the area of the circular cap, we can obtain that through the following integral. The area is the integral of 2 times pi times the radius times the ds. So we substitute the ds in here. So we need to integrate from 0 to theta of 2 times pi times the radius, capital R, sine of theta, and this times the ds, which is the radius, times the differential in theta. Now, as you can see in here, the only one that depends on theta is the sine of theta. So we can take everything else that doesn't depend on theta out of the integral. So we are left with this, the integral from 0 to theta of the sine of theta. So from this, we obtain that the area is equal to 2 times pi times the radius r to the square, and this times minus the cosine of theta, because that is the integral of the sine of theta, evaluated from 0 to theta. And then from this, we obtain 2 times pi times the radius square, and this times 1 minus the cosine of theta. And the flux is then the product, as I said, the product between the electric field and the area. So the electric field for this is 1 over 4 times pi times epsilon sub 0. And this times the charge times the separation distance square, which in this case corresponds to the radio, capital R. So we multiply this by 2 times pi times the radius square, and this times 1 minus the cosine of theta. So in here we can simplify some things. We can cancel this, and then from this we obtain that the flux, the electric flux in this case, is equal. We can also cancel pi with pi and the 2, so we are left in here with just 2. And then we obtain the charge divided by 2 times epsilon times 1 minus the cosine of theta. And this is the expression that we wanted to obtain from this. Now for part B of this problem, we are asked about what is the flux when theta is equal to 90 degrees. Now with theta is 90 degrees, we know that the cosine of 90 degrees is equal to 0. So immediately from the previous expression, we obtain that the flux, the electric flux is just the charge divided by 2 times epsilon sub 0. Now, if the angle theta is 180 degrees, which is the same as pi, we will obtain for the equation from before, this is part C, and we know that, well, let's substitute that in here. We have the charge divided by 2 times epsilon sub 0, and this times 1 minus cosine of theta. But we have minus, and the minus 1 of the cosine of a 180 degrees. So from this, we obtain 2. That cancels with this 2 in here. So the electric flux for that angle theta is equal to the charge divided by epsilon sub 0. So that's the solution for this problem. Thank you.